Hi, this is the Tempter podcast where we discuss embedded Linux, IoT development, and anything else we find interesting. Your hosts are Kim Raj and Cliff Brake. Hi, Kim. How are you today?
Hi, Cliff. I'm doing very well, and thank you for arranging this talk today. So I'm hoping we'll have fun.
Okay. So today we're going to talk about the Yoe distribution updater and all the neat stuff Kim has done recently with it. So let's see. Maybe to get started, you could just kind of share what an updater is, and maybe we could go through some of the options you looked at.
Yes. So I think, as we know, we have connected devices more and more. It's very important nowadays that you have a mechanism to update the device firmware or part of the device or some way to modify the device. And as we've seen in the past, we have seen a lot of devices that will be flashed once and then shipped with their products and will never be updated again. And that works fine for a certain class of devices, perhaps, which are not connected, and they don't have any further software components that they would require. But a new class of devices, in this more connected IoT world, has emerged, where your refrigerator is upgradable and your vacuum cleaner is upgradable, because the fact is they are running a lot more complex systems in software than they had in the past. So if you look at in the open source landscape in past 5-6 years, there has been many projects that has gained limelight, and many other proprietary solutions that have come and have been doing the rounds in this. So there clearly is a demand that we need to scale the solutions to not only some of the connected systems in the past, but a general solutions that would scale across different kind of devices. A fleet of heterogeneous devices, and so I think there is increased demand for that. So so it's also called OTA, over the air updates, or some call it like FOTA. This is firmware over the air. So there are various terms that are used to refer to updating system or maintaining the system in the field. And so I think that's where I think that this is a very important function, that is required. In fact, is one of the key pieces for any connected systems nowadays.
Yeah, that makes a lot of sense. And I guess one thing I've observed is these systems are so capable. You have an embedded Linux system, has lots and lots of RAM and flash, and the fact that you can do so many things with these platforms really lends itself to we want to deploy new software over time, because we want to keep adding features and functionality as new needs come up. So that's right on.
Right. So I think so on this, what you might have seen in the past few years, that there has been a good amount of activity in the software industry, especially in the embedded side of the things, that there has been solutions that has been proposed, and some of them work in one way, some works another way. But if you look at some of the things that we wanted to consider for Yoe distro, was we had a certain way to we envision the system to boot and to update. So we evaluated actually a few solutions, in that process, and then there were like all of them work in slightly different ways, trying to achieve similar results. And so that's where I think the interest was, because your distro, as you know, we intended to address certainly IoT market as a device software builder and infrastructure. So you could basically defer it to the user, saying that integrate something that you want, or we could basically take an approach that would integrate into the infrastructure at a distro level, and offer that as a solution, yet allow people to plug in if they want to plug in something else, is the approach that we chose for your distro.
Yeah. Okay. So what do you feel is different about the Yoe distribution updater? Like you said, there's maybe half a dozen projects out there that offer update functionality, and what do you feel we're trying to do differently?
Mm-hmm. So so I'll talk about like few of the things that we looked at, and then that'll hopefully help us reason why we are doing what we are doing in this space.
Mm-hmm.
So there are a few solutions out there. We looked at SW Update, which is open source solution. It's well integrated into Yocto project / Open Embedded or Buildroot, and maybe a few others, embedded system builders. And then there is some other solutions, swupdate, which is coming from Clear Linux distribution, and there is something which is based on binary tree models like actualizers, and so we looked at a few of them, and we experimented with the SW Update quite a lot. And there are a few commercial solutions also that are available, like Mender, or Cloud, or the Foundries. I think they do that at a different level, where they are trying to use different technologies to do update mechanisms, right? So some of them, they approach it in a way where they want to update. So they run loads as containers. So Resin, which is now renamed to Belina, for example, tries to run all your services in containers. So you have like a very minimum Linux system that does nothing but launches these containers, and then you have a system in place that updates the containers. And you can say, from a service point of view, that is your OTA, right? And then there is this another class of updaters like SW Update, which basically uses dual copy rootfs systems. So what they do is they have A and B scheme. So what they do is they were hooking up into your bootloader, and then they would have a mechanism to talk to one of the backends for serving your updates, and then they would be able to get the update and then flash it into the second partition. And then they will have a mechanism where it would switch your bootloader to boot from the second partition, and then they will have some control where they will assert whether the update was successful or not. And if it is not successful, then there is a mechanism to revert back to the previous model. So I think they also support a single copy update. So single copy update is when you have a rescue system which is basically invoked to update your regular rootfs. And once it's done, then it switches back to bypassing the rescue system. So in a sense, the functionality is very similar. So as we have seen, there are these different projects that are out there, And so, looking at these projects, we were basically deciding what our approach should be.
So with this rescue system, do you still essentially have two systems on your in your storage? Is that how it ends up falling out?
Pretty much, yes. So, you
Yeah.
can think of this that, you have a smaller rootfs and you have a
Right.
bigger rootfs.
Yeah. So you still have two essentially.
Yeah,
Right.
yes. So essentially, this is an approach to fit in the dual copy mechanisms into certain systems where you don't have, flash, where you can duplicate the rootfs.
Right.
So basically, some tiny systems where flash is very important. It's precious, and you still want to have, some update mechanism.
Right. Right.
But eventually, I think there are a lot of complications when you go and implement the update policy. So real issues lie in there, right? So because there is a full state machine that kicks in and nothing can go wrong. And if something goes wrong, your system is hosed to a point that it can't be recovered.
Right.
So
Yeah, that's the one thing with update systems. It's only as good as the weakest component because, this is involved with booting your system. So if it's all not perfect and it all works, you're done. So that's a
right.
very important distinction.
Yeah. So there are like things like you are writing the bootloader parameters, and then if something goes wrong during that time, then good luck, right? So it might sound that having two root FSs is giving you that peace of mind, but literally, if you look at, there are many failure points that things can go wrong, and it's been used in several places. I know where they have like a double copy, but then they in many cases end up having 4 copies because it's matter of trust, because they say, well, now I need to update the first copy, and now I need to update your static bootloader or kernel assets, and then say, but I can't do that, therefore I'll ship 2 kernels, and then I'll ship 2 bootloaders. And
Right.
so you'll have like your first disaster recovery system, and then your second disaster recovery system, and on and on.
Right.
So that also speaks to me that it has a failure concern that is not addressed, because we are trying to create these layers and layers and layers to address something that is not solved. So what I also looked at when I was looking at, say, SW update, and there's another one called RAUC, RAUC. Very similar in nature. They offer you like signing and verification and all that kind of thing, delivery of the payloads. That's all well. But I think one of the things that we were looking for is generally we want to also update our bootloader, we want to update our kernel, and we want to update our rootfs. In many cases, you would want to do that, and you may choose not to do it, but we don't want to limit an updater to not do it.
Right. Right.
And so these solutions are limiting you, from doing that. So I think we tried to kind of fit it into Yoe distro for a while. We got it working on Raspberry Pi, and it felt like we were trying to fit a square thing into a round hole. So
Right.
because that desire for us to have a way to update our bootloader and our kernel assets was coming in the way, right? And so anyway, our simple idea for us to update the bootloader, the system, was that we want to upload the assets in a simple way, and then we want to have a single mechanism that we can scale across different devices, and we can have a mechanism, a flexibility, so to speak, to update all these assets. So here comes the Yoe Updater. Basically, that is our good old tested and tried updater. And we reverted back to using that and making it more or less portable across multiple machines. And so I think one of the interests that I had is that, hey, can we make it more generic where we can basically, with little effort, port it from one device to another. And so I think what I have here is a BeagleBone Black. I have a Odroid C4, and I have a microchip SAM5 D27, and I have a Raspberry Pi 3 and 4. And I said, let's see, how long will it take me to port. Um, and so we started with this port essentially on Raspberry Pi 3. But one of the things that, for example, BeagleBone Black is eMMC based. So we also wanted to make sure that it's not limited to just doing SD card updates, but it could update any mass storage media that we use for our system. So I'll just describe what the updater is, and then I think we'll basically um, talk about the porting. So our updater is very simple. It is basically an initramfs based system. Our main kernel actually is a kernel plus initramfs. So we use, you can say that we use kernel as our updater at this point. So when you install a Yoe image, so what we did is we created additional images. One of them is called Yoe installer image, which is basically a factory install image, so to speak. So you would build the Yoe installer image, and it creates a flashable SD card image or whatever you use, like USB stick or what have you. And then you can flash it in. And then once you have that as that USB stick, either you can stick in your update, your real rootfs update, into that same USB stick, into the into the boot partition, or you could have it mounted through a USB. Say your board does have USB port, and so our initramfs system is very, very small. It's primarily BusyBox and a few other utilities and nothing else. And the size is somewhere around 2 meg or 2 to 4 meg at max. And most of it is glibc, really.
Right.
It's just the C library. But if you use muscle, it goes dramatically down to like 1.5 meg or 1.2 meg, something like that. So it's not huge in terms of, if people are thinking that, oh, you are including initramfs into kernel. It's not a whole lot that's in there. But now what happened is, once we have updater support for these machines, they go into our meta Yoe layer, and it will automatically include those updaters into those machines when you're building an image. So once you have included that image in the update mechanisms, you would basically go and do something like flash your installer image. And once you have flashed your installer image, you would basically have the updater image included either in the same media or in your USB media. And the updater, actually, I should have called it, it's an installer plus updater.
Oh yes, right.
Right. So
yeah, that's one of the shortcomings we ran into. We really realized that we also have to make sure the whole machine is initialized correctly. It's there's more to do than just an update. So
yeah, exactly. So so it can act in two modes. One of them is your installer mode, and one of them is your updater mode. And in your when you kind of like do your first time boot and install, it will basically set up your system to use the partitioning scheme that we have for Yoe. And our partitioning scheme is very simple. We have three partitions, and we call it like boot, root, and data. And boot is essentially, where you will put all your boot assets, your kernel or, device tree and your bootloader, whether it is U-boot or EFI or, other boot loaders, whatever the platform has to support. And then the root is containing your rootfs partition. And, it could be any file system you choose, ext4, it could be jffs2 or any file system you want to choose, depending upon what memory type device you have. And then there is a data, right? So data is basically for any persistent storage or assets that you keep for the system during this. So on your first boot, this is what it does: is it basically creates your boot media into these three partitions, and then it basically starts using it, and you could once your system is provisioned at that point of time, then right now our update mechanism is that you can have a we call it UPD file, and this UPD file is looked on boot. It looks for certain medias. It looks for if you have anything on USB stick, or it's there on data partition, and then it has elaborate checksums and everything to make sure that those files are correct, and then it applies the update, on the boot, and it has the smartness to find out if you're updating a bootloader asset and kernel asset, then it just updates them first and then boots your system and then updates the rootfs second time. This is just to avoid any kind of cumulative problems that you might have. So you want to make sure that you update them separately.
Right. Yeah, that's really neat, because it actually enables you to change the entire flash layout if you want. You can use a different partitioning scheme, or one thing I've run into several times is over time, as you add features, your rootfs grows, and eventually it doesn't fit in the partition you originally had designed. So being able to change the partitioning layout on the fly is a really neat feature. So I like that.
Yeah, exactly. I think these are like field issues, that you hardly see them like 7 years down the line, right? And the devices that we intend to support with these distributions are of 10 plus years, in many cases even longer. So having this in place at least helps the end users to think about it and say, well, we are having this support that we can deploy. And again, they can choose a different solution, and that's totally fine. But I think this solution that we have in place, our intention is to make it generic across Yoe. And we want to follow this, simple partitioning scheme for, boot, root, data, even for our development machines. Because most of the times, people have Raspberry Pi and BeagleBone Black and what have you, and it uses this simple SD card images where you flash the SD card image and it grows on first boot, and then you use it that way. But our idea is to kind of, have that partitioning scheme that eventually you would have in your deployed devices as well.
Right.
So it irons out a lot of issues, that you will have. Like, say, you choose to do rootfs, read-only rootfs, right? And you want to have certain read-write assets, right? Then you would be putting them in your data partition, right? Instead of putting in your root partition. Or so at least it gives you that opportunity from your design stages to make those right choices, and don't get all your system, it's working on Raspberry Pi, and then you say, oops, didn't think about, update, didn't think about this, and all that thing. So today, what we did was we ported on our Raspberry Pi 3, And if you today go and build, any Yoe image for Raspberry Pi 3, Raspberry Pi 4, Odroid C2, BeagleBone Black, they will have the updater in them, included by default. And so yes, it's as simple as installing it, and as we described earlier, using the Yoe installer image. Once you provision it, you just kind of like copy your updater image into your data partition and reboot your device, and an update is done on the reboot.
Yeah, that's neat because it's a solution that handles the manufacturing, provisioning, as well as the initial setup, and as well as updates. So if you want to add updater support to a new platform in Yoe, how does that look, or what's the process for that?
Yeah. So I think we have. I mentioned earlier that I wanted to do it on multiple platforms, and exactly the reason was to find out how much we can port it, or how can we abstract the common pieces app. So literally there are two things in there. One is that we have abstracted all the updater needs into a include file that you just include it into the images. And we have abstracted that include to be called with the same name as machine. Right? So if it is Raspberry Pi 3, then you will call it Raspberry Pi 3.inc or something. And it defines what your assets are, right? So you want to say, these are my device tree assets, these are my bootloader assets, these are my kernel assets, and this is my root asset. Once you have it, the common logic kicks in, and that basically uses those defines to populate your updater, basically the platform part of the updater.
So are all four of these platforms using the same common updater code now?
Yes.
Oh, great. Okay, that's neat.
Yeah. So they, as I said, they have a platform file, and platform file is where the differences are, because all of these devices, they do have differences in terms of what they call their bootloader, or even there are differences between Pi 3 to Pi 4. Right? So for example, their secondary bootloader is called, I think, kernel 7 in Pi 3, and in Pi 4 it is kernel 8. So
okay.
So even though they are very similar in nature, but there are differences when it comes to the assets you want to update.
Yeah. So we should probably explain that our updater is just a shell script. Well, has shell worked out pretty good for that, or do you feel it's lacking and could be better served by a real programming language, or what are your thoughts on that?
Yeah, I think so. We all know shell, and it's convenient, right? And I have
it's a pain, but it's convenient.
It's convenient, yeah. So we've got to point, and I don't see any limitations, so to speak, right? So we could implement all our logics, and we have done that. And that too using BusyBox shell. So we are not even using something like Bash or Z shell or some fancy other shells. So it's a rudimentary POSIX shell that we can get all our stuff done. But it's a shell in the end, so it's an interpreter. And I think eventually what I would like to see literally is in that this updater is re-implemented in Rust or something like that.
Okay.
And it becomes a single program, literally.
With like a declarative config or something.
Yeah. Something like, you have a single program that is statically linked and has a declarative mechanism to define your policy. And it's as simple as, bundling one program into your initramfs.
Right.
So, but I think that is definitely on our future roadmap. Rust sounds a very interesting approach.
Yeah, seems like a good fit.
Yeah. So in this case, because we need it statically, and we also want to make sure that we don't inherit all those flaws of older languages for security and void
Right.
pointers and all those kind of stuff. So
Hmm.
so we want to kind of like make sure that we can move away in future, uh, but right now what we have is pretty good. I'm very happy with it.
Yeah.
um,
One thing with Shell is it's really good at calling programs and handling the what happens, and that's essentially mostly what an updater's doing. You're running copy commands, you're
mhm.
running format commands, partitioning commands. So 99% of it is just simply calling programs,
Yeah.
and that's what Shell does really well. So
Hmm. Yeah, I think that's very well said because we do exactly what you described. Most of the time the logic is do this, if not this, do that, and all that are basically checking the returns values of another program being called. um,
mhm.
you know and one of the things I found pretty neat with busybox is that it uses applets. So what that means is not really forking and executing new programs. So
Mhm.
it's just the same busy box that you have loaded that is being called with different this applets. So we have tried to use as much as possible what busybox can give us. And obviously, there are additional like utilities that we need to have for formatting and stuff.
Mhm.
For dealing with like UBI and other kind of media. But um, I think most of like our formatting and all basic needs are filled by busybox, and it's pretty lightweight, and yeah, it can get a lot of things done.
Right. So I kind of interrupted you on porting this to a new platform, but what all pieces of the system does this touch when you port it to a new platform?
um, it touches two systems. One is your image,
Hmm.
um, and the other it is the updater itself, because you need to do the platform port. And literally, platform port is like I think 10 to 20 lines of shell variables.
Okay.
It's not a whole lot.
Hmm.
It's you need to declare those variables basically. Things like you need to say that my boot device is called EMMC, PLK01, or it's 0 or 1, or which device and things like that. So policies, you declare
Hmm.
them in that platform file, and that's pretty much what you need to do, unless you have a separate partitioning magic that you need to do, for certain files.
Right. So
And
there's no changes to the bootloader or the
no,
applications needed in the rootfs or anything like that for this
no.
to work. Yeah.
The only change I did have to do in the bootloader was for
Hmm.
BeagleBone Black, was to increase the size of the kernel that it allows.
Oh
Uh,
yeah. Right.
yeah. So right now, it allowed 8 meg, and our kernel was somewhere around 8.2 meg.
Hmm.
And I think that's just like a one-liner change in the bootloader. But I think we probably don't need that anymore because our updater is now small again.
Oh,
So,
okay.
but yeah, I think it's there are no significant changes that you will need to do other than adapting the updater and making sure that you do the image update.
Hmm.
Uh, so basically, we didn't talk about it, but updater is uh, is a step that we perform after we have built an image. So it's a post processing step that we do. So
Right.
yeah, so that post processing step would also is also abstracted in the similar fashion that you do for updater. You define your variables in there, so you can tell the updater that these are my assets that I want you to create.
Hmm.
And we talked about, somebody may say, bootloader is a done deal for me. I don't want to update it in the field. kernel is a done deal for me. I don't want to update in the
Hmm.
field. Totally fine. Define that in the policy, for your updater image, and it will only include in the updater what you want, right? So say you are only interested in updating the rootfs, no problem, go for it.
Hmm. Yeah, that's great. So to add it to a new platform, all you have to do is really use the rootfs tooling you've done, and then create a small platform file that defines a few variables,
Hmm.
and boom, you have software update
Yep.
for a platform.
Hmm.
So yeah.
So that's where it stands right now. But as you might have noticed, it's more or less manual to update right now.
Hmm.
So what I mean by that is that you have to like define maybe a service or something that would eventually go and fetch the update. All that logic is not there yet.
Hmm.
Where you can go and figure out the update strategy. You know.
So right now the process to update is you put an update file on a USB disk, you stick it in the board and
Hmm.
boot it. It finds the update on boot, processes it. And so that's kind of the simplest way to use the updater.
Hmm.
Well, one thing I think it's important to note is that's a very useful feature as well, because as long as your kernel boots, you can recover
Hmm.
a unit if the rootfs got corrupted or whatever. So
Yeah. 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 Yeah, right. And second way is that you can copy or download, so to speak, right, the updater into your data partition
hmm.
on a booted device. That is more or less non-interactive, so to speak, right?
Right.
And I think we'll build services on top of that where it will be more automated, and that's to come.
Yeah. So that process would download an image, stash it in the data partition, reboot, and then the updater on boot would see that update file in the data partition and run it then.
Yeah,
So
yeah.
yeah.
So um, and we do also have splash update as well, part of it. So
Oh,
if you have a
so progress bar, huh?
yeah, so
Yeah.
if you have a headed unit where you have a LCD or something connected, you can add progress bar, and you can dump in your own logo or something, so it looks nice and fancy. So
What program are you using right now for the splash screen?
I think it is basically just the splash. I forgot
Is
what
that
it.
is that P Splash? I mean, that's
Yes,
what.
it's P Splash. Correct.
Okay, so still P Splash. Great. Okay.
Yes, it is P Splash.
Hmm.
Yeah, I was forgetting that name, but yes. So, but yeah, I think it is basically at that point when you want to get notified of some things that what's going on. You can program those things, and
Yeah.
the neat thing is all that is nicely tucked in into the updater logic in the script, and you can enhance it if you like
Right.
to if you want to say add more steps or something like that.
Hmm.
That's definitely doable.
Yeah. Yeah, it's kind of a neat thing because you can easily add functionality to this as well if you have some custom initialization code you want to run or custom
Hmm.
checks.
Hmm.
And
Yeah.
I would say for system reliability, you really want to have full control over, especially your data partition that gets written too often. That's the one that's in the greatest risk of being corrupted
Mm.
and rendered unmountable. Which I've hardly ever seen that. I'm amazed at how robust these systems are. I've just rarely ever seen a file system
Hmm.
become corrupted to the point where it's unusable. So
Hmm.
we're starting from a pretty solid foundation. But yeah, if that happens, you know, I feel for most systems, you really want them to still be able to boot and run, even
Yeah.
if you lose your data partition. It's one thing to lose all your data, but it's another thing if the system's just bricked and it won't do anything. So
Hmm. Hmm. Yeah, totally. I think sometimes these systems are in a location that is like not approachable anymore, or
mhm.
without uh, a lot of effort. So these are not some servers sitting in a data center in air conditioned environment. So
Right.
so I think it's kind of a different scenario, so to speak.
Hmm.
And so certainly your policy changes a little bit in that regard.
Yeah. And one thing I've found is it's a whole lot easier to do these things in your initramfs
Mhm.
where you have full control over the system than to try to shoehorn that stuff into system D or the Linux
Mhm.
init system where you've got multiple things happening at the same time and race conditions.
Yeah.
For stuff this low level where you are initializing the basic file systems on the device, it's much easier to do it before you try to boot the system than while you're booting the system, just because of all the dependency problems.
hmm I think I totally
So,
agree. I totally agree there. I think keep it simple is really
yeah,
the mantra, right? And
right.
I think that has been what we've been trying to do with Yoe in general, and that has been just translated into our updater selection and design. So I'm pretty happy with it right now. I do a lot of open embedded work, upstream work, and
Hmm.
earlier, I would pop out a micro SD card and flash it on my device, on my PC, and plug it back in. And now I don't do that anymore. So I
So you're
just
saying even as a developer, it's actually a useful feature that helps you as a OE developer. Yeah.
yeah, it definitely does help. I mean, if you look at it, and in one of these days, I might do that. In at least in my own automation here, where um,
Hmm.
I do a build, right, and then in the build, I would basically secure copy the updater to the device, and then knock it off, to reboot,
Hmm.
and then wait for it to boot up, and then run my tests.
Yeah. So you could build that all into your CI
Yeah,
pipeline and.
exactly. So, and use some TCL script or something, some expect, or whatever your favorite
Hmm.
poison is there to design these logics. You could do that. But one of these days I'll definitely do that, because right now what I do is a little bit of manual work where I scp it
Hmm.
after the build. In fact, that scp is automated already,
Yeah.
so
Okay.
it knows which machine it is, and it can map that to a IP address, and it just scp it is there. um,
Hmm.
but yeah, so it's very helpful, actually. I think I didn't realize that how much time I was spending, in popping that disk out, pushing that into my USB, and
Oh yeah.
hoping that I didn't wipe one of my own disks.
That's just friction. So anytime we can remove friction, then it's yeah, that's great. So yeah, I
Absolutely.
like seeing solutions that are just useful in all these different contexts.
hmm
And
Absolutely.
so
Absolutely.
yeah, and it's really exciting. We've discussed some automation for deploying updates from the cloud. We're talking about integrating the simple IoT system to handle firmware over the
hmm
air updates.
hmm
So you mentioned that before. So those are some of the things that are very exciting that we hope to bring online soon.
Yeah, I'm really looking forward to have this implemented in simple IoT.
Hmm.
Um, where we can have the fleet management for update. So basically, I don't know how that feature is going to look like, so I don't want to define it here, but it's something that uh, we could basically have in simple IoT, doing the management, and maybe there will be a simple IoT backend where we
Hmm.
can host the assets, and it could be stepping even a bit further. We basically, for your releases, um, have the release assets for some of these machines made available, so somebody doesn't have to build. They can just take the SD card image, flash it, right, and then bring it online, and then it can connect to one of their simple IoT servers, and fetch the latest update and update the device.
Right.
And we can have such a simple IoT instance for our developer community and users
Right.
to play with.
Yeah. Okay. Well, stay tuned, and hopefully we'll have some good news on all that in the near future. So, yeah, appreciate you sharing this this with us, Kim, and it's really exciting to see this come together. So,
yeah, thank you, Cliff.
So, anyway, that's all for today, and we'll appreciate you listening. And
yep, thank you, and stay blessed.